and I will welcome everybody to this year's 30th anniversary, or 30th version of the Little Shop of Physics Open House. And this year it's virtual, and we're going to show you why, because we're going to kick things off with a little video of our open house from 2 years ago. And I would just take a look at this video, and you can see why we're virtual this year.
I can already tell that.
Oh, look at all those people super close together. Awesome, awesome. Look at this microphone here. Have some COVID. This is awesome. So clearly this level of closeness, this level of sharing among these people standing so close to each other, we absolutely can't do in this era. But we're really sad because the energy and the spirit of the open house, 10,000 people came last year and showed up, and we're experimenting and exploring and do all these amazing hands-on activities with families and with friends. And that spirit is something that we will return to. We will be back. Once we are able to gather together, we will be doing Little Shop of Physics hands-on again. But until that time, there's still a whole lot that we can do. And one of the things that we want to show today in this program is all the things that the Little Shop of Physics team has been doing to stay connected. Because our theme this year is we are still connected. Even in this time, we are managing to stay connected with the people because the relationships are a really, really important thing. We love sharing science, not just because science is awesome, because it gives us a chance to interact with such amazing people. So let's go ahead and kick things off, and let me describe briefly what we have planned for you today. So we're going to show you some cool demonstrations in the spirit of a Friday program we've been doing called Little Shop of Physics Live. Every Friday we're live and we do the Zoom cast, and we're showing some interesting science demonstrations on a topic, and we've been working a lot with the local Poudre School District, but it's not limited to the Poudre School District. Anybody can go in, and I bet I could convince Adam to put this in the chat, and you're going to be seeing a whole bunch, or a link to that in the chat. I'm betting you're going to be seeing a whole bunch of people from the Little Shop of Physics live team and the people who are part of that. And then you're going to see people from other things that the Little Shop of Physics is doing. And then in our second half hour, we have something really special. We have invited some people to join us from other places around the country and around the world, because we are still connected, and we have partners all over the place who we have still been connecting with, and we've still been doing interesting science with. And we're so happy that so many of you have showed up on a Saturday to stay connected with us. So I'm going to start with a quick demonstration. This is in the spirit of the Little Shop of Physics live show. Every week we put on a program, and there's a theme to it. And the kinds of things we do is little demonstrations that use everyday parts that people can try themselves. And I'm going to do one that uses a container full of water, and I'm going to pour in some kerosene. And kerosene's oily, and it's going to float on top. Like most oils, it floats on top of the water. And Brennan, we tried this yesterday. We tried on a show, we did a thing called Science It Up, and we tried to come up, one of the kids, we were addressing kids' questions, and one of the questions was, why does oil float? And we tried to make oil sink.
Doesn't work.
Doesn't work. We were not able to.
Nope, we tried. We tried. Can't get it.
We tried, but doggone it, we failed to make it sink, but we learned something about oil and water and density. And I'm going to put in a whole bunch of plastic beads. And the plastic beads, if you look at them, they're floating at the boundary between the oil and the water, okay, or the kerosene and the water. But something really amazing happens, and this is something that we found a couple years ago when I was working with a student named Bo, who was an intern with Little Shop of Physics. If I take this and I shake it up, what ends up happening is I get these little units that kind of like cleave off. Oh, there's a giant
big one.
Oh my gosh, that is delightful. And that is a little glob that is basically a whole bunch of pellets that are held together by kerosene that have surrounded the water. And it's made something like it's like a little cell. It's held together by the forces between the plastic and the oil, much like the COVID virus has a little lipid bilayer that surrounds it, and that's what holds it all together. And if I want to disrupt the COVID virus, or if I want to disrupt this little micelle, I'm going to call that's at the bottom of the container, what I need is some soap. So I have that little doodad, and it's just hanging out in the bottom, and it's a chunk of water surrounded by kerosene and pellets, and it's held together. It's like a little membrane. And the density of that is greater than the density of water, and it sinks if I put in a little bit of soap, and it doesn't take much. What the soap will do, oh my gosh, what the soap does is it disrupts all the forces
Oh,
that
that
are
thing
holding
just
together all of
disintegrated.
the layer, and that thing is completely dissolved. A little drop of soap, and we have completely destroyed that. And that's why in this COVID era, we're asking people to wash your hands and wash your hands with soap. The soap is crucial for disrupting that lipid bilayer. So that's a little demonstration in the spirit of the Little Shop of Physics live show. And then we have a whole bunch of other people who have been part of the show who are going to share some things with us. And next I'm over to Sheila, who has been my partner for many, 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 many years.
And this is my I think I'm turning the wrong way. This is my
That's okay. Got a little Einstein sticker.
I felt bad. Everyone else had a really nice decorated mask and face mask, and I didn't. So.
And Sheila's got a container that looks like water, but it's not water. What's in there?
I have a solution of sodium acetate, and I'm going to pour it into this beaker first. And this is a super cool experiment.
Oh my gosh, it is literally super cool.
Oh no! It's freezing as a Oh man! Look at that! It froze in the bottle!
We knew that was a danger. That liquid that was in the bottle was super cool. And as soon as it starts to freeze, the whole thing just goes down. And so I think, Sheila, that demonstration didn't happen the way we wanted it to.
It did not.
But it happened kind of awesome.
What's so great about this is this is in hand warmers that are reusable. And so the sodium acetate is cooler. When it's a liquid, it's cooler than its freezing point. Obviously, it didn't take much for it to turn into that. But I thought it was topical that we would do this super cool experiment because it's winter. And you can do something with water as well.
Oh my gosh! Let's see what happens.
And
with
I'm
the
a
water.
little nervous, Brian.
I think
These two could both not work. I'm not sure.
Nothing worked. It just worked different. So Sheila's got some containers of water, and these were boiled and then put inside those plastic bottles. Are they liquid? They are liquid.
They're liquid. Let's hope that.
Okay, and if you take one, and it's liquid water, but hopefully below its freezing temperature. If you take that, maybe smack it on the table.
No, that one's still liquid.
That one's still liquid. Or if you shake it, there's another thing you can do with it. Give it a shake. Sometimes.
No.
Still liquid.
Shoot,
Still
not
liquid.
enough
That's okay.
time in the fridge. I have 2 more.
That's okay. We got 2 more. And then also, I think you got a soda in there too.
I do, and I'm hoping that'll work.
And if you have things in
something
the
has
freezer,
to work, right?
What's that?
Something has to work for this
No,
experiment.
I think you are already. This is a really kind of finicky thing where we're trying to super cool things, and then if you have them below their freezing point, if you trigger the freezing, the whole thing will go. But these are not quite cold enough. I'm thinking.
Not quite.
Not quite cold enough. We didn't wait quite long enough.
That water's being stubborn.
That's okay. And how about the Coke? If you open it.
No, it's still a
Give it a shake. Give it a shake. Too. If you give it a.
Although it is it's slushy.
No, it's slushy.
Look at that.
It's slushy. And I'm going to aim it at the camera.
Sorry
so you can
about
see.
that.
That was super cold, and it turned slushy on top. You just made a Diet Coke slushy. It's what a regular Coke slushy is what I'm seeing right here.
Yeah, there's like a chunk of slush
of
in
ice.
there. I don't know if you can see
It was
it
ready
or
to
not, Patrick.
freeze, and then Sheila just hold it still like that so Patrick can zoom in on that, and there's a chunk of ice in the top. When you opened it, it was super cold, and it formed a little bit of ice right there at the top, so we got a little bit of Coke slushy. Awesome. So we did get a little super cool action happening here, which is fantastic.
Oh yeah, it's up there. But try this at home.
Absolutely. Put something in the freezer.
Yeah.
The timing is crucial.
The
as
timing
we
is
see.
crucial.
A little finicky.
And also, I tried it in a snowbank before, and it worked with
Awesome.
soda.
Awesome. And now we're over to Brenna, who's going to share something from the Little Shop of Physics live show. This was kitchen chemistry?
Yes, it was. And this was one of my favorite demos that we've done thus far this year. So here I have some cabbage water. Basically what I did is I chopped up some red cabbage right here, and I poured boiling water over the top of it, and I made this cabbage tea, which is kind of disgusting. But it turns out that this cabbage water can do some pretty awesome things. It's a very good pH indicator. So I'm just going to pour relatively equal amounts.
That's relatively equal. That's pretty close.
In Brian standards, yes.
Yeah. Yeah, for me, those are equal. Darn it. Those are equal.
But I have an acid and a base here. I have ammonia, and then I have vinegar. And if I pour the ammonia in this cabbage water...
Whoa, it turned blue.
Look at that color change.
It turned blue.
And I thought this was super awesome because, you know, I test the pH of my fish water every week, and it's super important. And the fact that you can do this in your kitchen is awesome.
And if you pour it in vinegar?
Yep, this is vinegar. If I pour it in there, look at
It
that.
turned red.
Look at that.
And it totally matches like the tie-dye around the room. These are three colors that go really well together.
It does. It's kind of awesome. So.
And so you've made a color-changing thing with just kitchen chemicals. And that was the theme of our kitchen chemistry show. Oh, now you're pouring it all together. We're getting some bubbling going on. I am. A little chemical reaction. And that dovetails nicely with our next show, which is going to be chemical or physical. And it's fantastic. And next, I see that Emma is getting set up. Emma, what do you got over here?
Yeah, so I am making a density jar, which is really cool. We're going to do some unmixing here. And it's a super, super cool process. So I start by filling this bottle here halfway with 91% isopropyl alcohol.
Awesome.
Yeah. Okay. Easy. And then I'm going to mix it with just water. And this is distilled water, so it's filtered. There's no, nothing else in it. It's just water.
And it looks like the water and the alcohol are handily mixing. They're turning a little bit cloudy, but now it looks like it's clearing up.
Yeah, so they've mixed together.
And so you're going to basically socially distance these things, right? Is that what I'm? That's what
Yes,
I'm seeing. Like you're going to socially distance those liquids.
I'm going to social distance the water and the alcohol. But first, I'm going to do something kind of fun and dye it. We're going to dye it purple, just because purple's a fun color.
Purple's an awesome color. That's why we have purple in our shirts. Oh, you put a little bit of pink, which is awesome.
Yep, and combining it with some blue.
And these are just the guts out of highlighters, right?
Yes, these are just highlighters. And of course I'm using gloves because it's messy. Okay, and then I'm going to quickly cap it and mix this.
Oh, it makes a lovely kind of like purple-pink color. Yep. I love it.
Just purple. So obviously this is just one color. But now if I add a bunch of salt, like a ton of salt, like a lot of salt.
Well, that is a lot of salt. There's a lot of salt.
Just pour it in the top. And it's going to take a second.
Oh man, you are seriously salting that thing up.
Oh yeah.
Boy, it looks like I'm seeing a little bit of a color change as you're doing that.
Maybe.
Which is kind of awesome.
But what's going to make it even cooler is I'm going to shake this really hard.
Awesome. Shake it up, baby.
And then we should see a separation.
Oh my gosh. I'm starting to see a
You can kind
separation.
of see it. It's starting to form
Look at the bottom. The bottom is blue and the top is pink. You've socially distanced the liquids.
Yes, by adding the salt, we completely separated the water and the alcohol.
Oh my gosh,
so the water is more dense, so it's on the bottom.
Oh my
and
gosh,
the alcohol is on top.
And it's pink on the top, and it's blue on the bottom.
Yeah, and that is likely because the pink dye is water soluble, or alcohol soluble, so it mixes with the alcohol, and the blue dye mixes with the water.
Oh, so you took purple and you separated it out into pink and blue, and you took alcohol and water and separated. That is delightful. Emma, thank you so much
Yes.
for sharing that. Perfect. And now I see I've been joined on the other side of the table by Maud, who's got a little demonstration for us. And this was from an episode. Do you remember what this one was from?
This was just from the water show.
The water show.
Yeah.
Okay.
The H2O show. So here I've just got just a little glass bottle that you can get from basically anywhere. And I'm going to fill it up with water to, whoopsie daisy, about probably...
And you're going to pour some on the table too, just cause.
You know, if we don't make a mess, it's not really Little Shop. Let's
of
be
business.
honest with
That's
ourselves
not our
here.
way.
So I think right about like an inch below the neck is about right?
Looks good.
Yeah. And I've got a super fancy little tire thing that we probably just yanked off of some poor kid's toy.
I think we probably bought it at the store, but I like the idea of yanking it off a kid's toy.
And I'm just going to hit the top of the bottle here, and this is just one of the most amazing properties of water, is...
Oh, what? Well, I heard it clank.
Sound is the water, when the bottle gets moved down, it's smacking the bottom of the bottle.
Whoa!
And if I hit it hard enough, I make a mess.
Even more of a mess. And you broke the bottom of the bottle right off. But it wasn't Ma that broke the bottle. What broke the bottle?
The water did.
Water. What? You can break a bottle with water. That is an awesome demonstration.
A messy one, too.
And a messy one, too. Which, of course, it's a little shop of physics, and so we would expect nothing less. And then that little shop of physics lab, every Friday we got that going on. And this is the kind of stuff we do. It's little experiments using simple tools. We hope that kids try this stuff at home, and we're connecting as much as possible with the things that the schools are doing. And that's just one way Little Shop of Physics is staying connected to the local community during this time. And next, we're going to talk about some things we're doing where we're staying connected as well. We're going to talk about work we're doing with the Boys and Girls Club. And this has been led by Heather, who is a Little Shop of Physics person of long standing. And we should have a video that shows like the work we're doing with the Boys and Girls Club. And then hopefully Heather is joining us pretty soon here. And there is Heather. And that's a video there. Let's pull up a video of the work with the Boys and Girls Club. Excellent. And while Heather's getting set, I can talk about, and Heather, this is like the kids at the Boys and Girls Club, and then it looks like CSU students connecting over Zoom. Is that what's going on?
Yeah, so we were wondering, like, how do we do outreach in this COVID era? And so initially last semester, what we did is we ended up connecting with folks over Zoom, and we had one person go on site with cool hands-on stuff, and everybody else talked to him over Zoom, and we rinse, repeat, do the same thing this year. And the great thing is the kids get materials to take home with them, which is important. So we have single serving science for them.
Single serving science, I like it, which is very COVID safe. And speaking of that, Heather, you can take off your face mask if you want in this zone. We have shields up between our stations. We are all socially distanced by giant sheets of plexiglass and our face shields. So we are staying safe, but everybody out in the hall is totally masked up. We are maintaining distance. We're maintaining masking. In this zone is the only place, and you're in the safe zone. So you got a little demo for us, I see.
Yeah, so this actually was a demo that our Norwegian friends shared with us. And I was putting this together this morning and put it together the wrong way, but we found out it actually works really well. So all I'm doing is taking this green balloon and opening it up and shoving in this red balloon. And then, lost a little nozzle in, that's okay. Now I'm going to fill these balloons up with air. So pumping this up.
I'll mention too, you're pumping it up with the pump. We're not getting anybody's like little respiratory droplets in that balloon because we're gonna bust this thing, I understand.
Oh yeah.
Oh yeah.
And so what I have on this table here in this case that looks like a piccolo case is actually a laser. And this laser is a green one. And initially one would think with the green laser, we could tie this up, that it would pop the green balloon.
I would think, like, if it's a really powerful laser, it's going to, like, destroy everything in its path.
Yeah, and the interesting, so it's a very bright laser, and this is what I use for astronomy.
Whoa!
Whoa!
That was kind of awesome.
All right. And this is, in science, sometimes you got to try things.
You know what you could do, Heather? Rather than tying it, go ahead and blow it up.
You're going to hold it?
I'm going to hold it.
Oh, you're going to be brave! I love it. I love it.
You can blow it up, and I will go ahead and grab it, and we're going to have it right here. I'm going to be your clamp.
Thank you, Brian.
Okay, so there we go. I'm holding it.
All right. And I gotta say, so this is the coolest birthday present any spouse could give their spouse. So thank you, Tim, for the coolest present ever.
And you're aiming your green laser at the green balloon with a red balloon inside.
And I'm gonna, because I'm so excited, I think I'm a little jittery, so I'm gonna set it on the table.
Oh, what? The balloon inside, but not the one outside?
So what's happening is the green laser is actually, the balloon's a little translucent, and the green laser is going through there and being absorbed by the red. Why we see red is because it's absorbing all other colors and then reflecting out red. So it's absorbing the green, whereas the green, mostly reflecting it, but we found transmitting just a little bit.
That is kind of awesome. And I'm just going to let this thing fly because that's something... which is kind of awesome. And Heather, thank you for that. Thank you for that. And thank you for sharing a little information about what's happening with the Boys and Girls Club. And that work, too, is going into the schools. We're starting to do virtual connections with the schools. So if you're a teacher and would like to have the Little Shop of Physics team zoom into your classroom and share some stuff with your students and do some single-serving science, that's a thing we can make happen. And then I'm over to Nina, who has been on the Little Shop of Physics live program, but now is working with the Classroom Connections team that Heather has put together.
Yeah, it's been awesome. I'm so glad that I've been able to get into the classrooms, but remain COVID safe, but still interact with people, because that's not the norm right now.
Awesome. So what do you got for us?
Yeah, so this are just tanks and containers filled with water that have food coloring in them. And it turns out you can actually use these to reveal secret messages that I've written.
Secret messages?
Yeah, so if you look here, I've written something that this just looks like a bunch of mumbo jumbo, doesn't it, Brian?
It does.
Doesn't look like it says much. But if we place it behind this filter, it reveals a secret message.
We are all still connected.
Yes, which seems very fitting.
Oh my gosh.
And then if we place it behind the blue filter, let's see what it says.
It says Little Shop of Physics.
Yeah, so you can actually see the different colors. So with the different color filters, this is just highlighter.
Well, you just use different colors on highlighter. And go ahead and hold it steady so we can take a look at that. It looks like you got blue highlighter and pink highlighter and orange highlighter.
Yep.
And then tanks filled with red food coloring or blue food coloring.
Correct.
And let's see that one more round. Let's do one more round of that.
So this is the red.
We are all still connected.
Yeah. And if I pull it up, you can see the letters that you're seeing are the blue highlighter.
Whoa. And then when you put them down, it disappears. And this is something kids could easily try at home.
Yes, exactly. And then behind the blue, Little Shop of Physics.
There's Little Shop of Physics.
And you're seeing the red and orange highlighter.
Oh my gosh.
And that's because the blue filter, for example, is canceling out the blue highlighter, so it blends in, so you're not able to see the letters written in blue. And it's the same thing happening over here with the red filter.
That is phenomenal.
Isn't that awesome?
Nina, thank you for that. And over on the other side of the table, we've got Reagan. And Reagan, you're even labeled. I love that face shield that you've got. That is delightful. And Reagan has been putting together kits that we've been sending all over the country, actually. And you got a kit with you, right?
Yeah, so I have one piece of the kit, which has refrigerator magnets.
Awesome. And if kids wanted to try this, they've got refrigerators. Those refrigerators have magnets on it. We know that's true. So show me what's cool about the refrigerator magnets.
Yeah, so, and these are just regular refrigerator magnets, nothing special about them. So I have the picture side and the magnetic side. And if you want to try just sticking them together, dragging them together.
Well, it looks like they're pretty sticky that way, pretty slidey.
Yeah, and then here, nothing happens.
Not sticky at all. Oh my gosh.
And I also have a piece of magnet view paper.
Oh, and so you can actually see the poles.
Yeah, so this shows you how magnets are magnetized, and it has little bits of iron filing in it that help with that. So when I put it on the back side,
oh yeah, I can see lines.
Magnet, you can see little lines, which are how refrigerator magnets are magnetized. But if I put it on the white side, you actually don't see anything.
See nothing. So all the magnetic field is on the back side. So refrigerator magnets have a sticky side and an unsticky side. I think we need to demonstrate this, and I think we need to go bigger. Reagan, are you prepared?
I'm ready to go big.
That's a little shop of physics thing, and folks who have worked with us over the years know we go big. And what do you got here? Let's go ahead and hold up what we got, and let's turn it this way so folks can see it. Tell us what this is.
So these are actually 2 big sheets of refrigerator magnets. We cut them, and I put some grommets so we could attach a rope. But yeah, this is basically just a larger version of this.
Whoa. So if I had a really big refrigerator, this is the magnet that I need right here.
Yeah,
awesome.
for sure.
And if I take it and yank, man, this is like...
Ah!
We got it. That is awesome. So this way, super, super sticky.
Yeah.
Oh yeah, that is not coming. That is not coming. But if is there a way I can make them not sticky?
Yeah, so actually, this way
What? That way it's like...
doesn't stick at all.
And actually, you don't even need me for that. Look at
Yeah.
that. So not sticky at all.
So that is like the picture side on
That's
these
the picture.
magnets.
Oh.
And then this side is the black sticky side. It's really hard to take apart.
How about if you take it and rotate it by 90 degrees? What would happen then?
Let's find out.
That's the spirit. Oh my gosh. And if I rotate by 90 degrees,
It's sticky, but not as well.
not as sticky. So a little bit, I might even say a little bit slidey. Mm-hmm. That is awesome. Reagan, thank you for that. And these kits, we're still making more, right? I saw you packing up something this morning.
Oh yeah, we have over 500.
Oh my gosh. So a lot of kids are getting a lot of single-serving science out there, which is fantastic. And I see, I've been joined at this is awesome. Like every time I turn left or right, there's a new human being there. And this is Elizabeth. And Elizabeth, I saw some of your people on this morning. Oh, and look at the decoration on that headgear. Oh, I'm loving it. I'm loving it. And Elizabeth, what do you got for us?
So I have some polarization. First, if you want to do this at home, you're going to need some polarized glasses. It should say polarized on the side.
Uh-huh.
But today we have a filter. So
Ooh.
what you're going to do, and to show you what happens, is
That's
if you
just a laptop screen, right?
Yes, this is a laptop. Laptops and phones have polarized screens, so it's giving off polarized light. And if you put this in front of it, you can't see anything. But as soon as we put a filter in front of the camera...
Whoa. Oh my gosh, look at those colors. That's phenomenal. That is phenomenal.
And then as we're turning it, it even changes colors.
And you could just do that with a pair of polarized sunglasses. And what's on that piece of thing that you're holding up in front of the laptop?
So this is actually a transparency and tape. You don't have to have transparencies. I actually have a Ziploc bag. And if you want to do this at home, with parents' permission and help, you're going to cut open the bag so you only have the clear side. You only use the clear side. And then you're going to take some tape. I have some right here.
And you're prepared. You got tape right there. You are super prepared. This is great.
And you're going to put the tape on the clear side. You can cut different sizes. So I have a small one. I have a really big long piece. I'm going to put it on different ways. And then I made another piece over here to show all what happens at the end.
Oh my gosh, look at that. You've made like artwork using polarization.
Exactly.
Oh my gosh. And this is something folks could totally try at home. This is very much in the spirit of the Little Shop of Physics Live. And I think when you're working with the Boys and Girls Club, you've been having to make art this way, haven't you?
Yes, we have.
Oh my gosh. That is totally, totally delightful. Elizabeth, thank you for sharing that, and thank you for being part of the team that is sharing science with kids out in the world. Thank you very much for that. One other way which we have for people to get involved is through this thing called the Art of Science Contest. And this is being run by Adam Perlstein. And since Adam is running the tech, I'm going to talk about this. And these are some entries that were received in the fall in the contest. But there's a spring contest that is going on as we speak. And if folks want to participate in it, you can go ahead and make a submission. And last fall, it was just the upper grades, but now it's opened up to all grades K through 12. And so if you want to participate in the Art of Science contest, you can submit an entry, and it will be judged by and you'll get feedback from a team of Colorado State University students. And so this is another way that we're staying connected between people in the schools and people at Colorado State University, because it's that connection between the people in the schools and the people in our school that we really love. Oh my gosh, that's a gorgeous picture right there, the Aurora Borealis. And this is some of the entries that we have. And if you want to take part, there's a link right there in the video, and I bet Adam is going to put it in the chat as well. Next thing that we want to do is we're going to turn to some of our partners, and we have a quick slideshow of Little Shop of Physics around the globe that we're going to show. Because Little Shop of Physics, we started in Fort Collins, and that's our home, and we love partnering with the local people and the local schools. But we are not constrained. Well, right now we are. But eventually, we're going to jump on airplanes, and we're going to travel around the world. And this is Little Shop of Physics in Uganda, where we went in the summer. And then this is Little Shop of Physics in Mexico. And then in Slovenia. And there's my friend Chris Chiaverina, who you will see in a little bit. And there's another thing from Slovenia. I'm spraying children with water, which is kind of awesome. Here's us in Norway. We were hosted by the folks from Science Circus, and here's the Science Circus teams, and you can see there's flames, and I think we might see some flames later. And here's a group in Namibia. We did some teacher workshops in Namibia, more teacher workshops in Namibia, and there's Patrick, who's usually behind the camera, so you're not seeing him. More work in Norway, and there's Jørn, who we're going to see later. And here is in Mexico, another trip working with teachers, Norway, and then Magne, who is someone else we'll get a chance to see in a little bit. And in Namibia, with Heather. So we get out and about. And then more in, I think this must be Mexico, and there's Chris Chiaverina over there. Awesome. Oh no, this was Norway. Sorry, this was Norway. And with Chris, and we did a workshop with some teachers there. So we want to make the point that we're all still connected. And one of the best ways to do it is to be able to connect with some of our partners who we haven't had a chance to work with in person, but we have stayed connected with. And we've asked them to join us for a very, very special piece of this year's open house. We have a series of partners. And first, without further ado, we're going to zoom over to Norway and join our partners from the Jærmuseet Science Circus. Take it away. Oh, love the shirt.
Hello.
Hi.
My name is Jørn. I'm part of the Science Circus of the Jærmuseet in Norway. And with me today in this beautiful location are Magne and Fredrik.
You guys have like 3 years of Little Shop of Physics shirts. Good on you.
Oh, yeah. So me and Fredrik did a presentation at the open house last year, and Fredrik was really sad that he wasn't allowed to put things on fire. So for today, it's really good to have it over Zoom, because our theme of the day is going to be top 3 things Brian really likes to at Open House 2020. So for number 3, we have the Norwegian hand sanitation.
Okay, as you may notice, we're not wearing face masks and not keeping a really long distance from each other, but the reason is not political at all. It's actually that in the region we live in Norway, there are almost no COVID-19.
We've been good.
Yeah. And also what we have of COVID-19 is brought down by social distancing, isolation, and tracing. So we're good. Yeah. And not to forget the way we sanitize our hands.
Yes.
This is brought down by generations to the next generation from the Vikings.
Yeah, dating back to Leif Erikson, I think. Yeah. This is how we do it.
And 2.
Awesome.
Yeah, so this is, Brian was just talking about things that you can do at home. This is probably one thing you should do at home. And the reason this works is because the cotton burns really quickly. We've chemically attached oxygen to the cotton to make it burn really quickly. And also we wet our hands, and the water absorbs quite a lot of the heat, so no damage.
Awesome. Yeah, you look undamaged.
At least physically undamaged. That's good. So next,
next for the next thing that we weren't allowed to do last year, it's we have the sound barbecue.
This is not the official name. The official name is Rubens tube. It's actually one of the first ways to show sound waves. And you'll see the top of this tube will change.
Whoa.
So what's happening is that the sound waves are traveling down the tube, and sound you may know is actually waves propagating through air. But inside this tube, we don't have any air. We have a flammable gas. And there we go. And when the sound travels from one end of the tube, it hits the other end and is reflected back. And the waves interfere when they meet up. And I think the right thing to do now is play some music. We can do this all night long, but we were only allowed like 5 or 6 minutes. So
Yeah. So for the number one thing that we weren't allowed to do last year, we have the do-it-yourself Northern Lights.
Yeah, and the reason is clear. Norway is known for Northern Light, or Aurora Borealis, as it's known. Just turn that off. Sadly, where we live, we rarely see Northern Lights. That's because we're all in the south of Norway. But one other thing that makes it rare is that we seldom have clear skies. We have a lot of rain.
yeah.
Our Northern Light is created when solar particles travel against the Earth's poles, magnetic poles.
Yep.
And when they meet the atmosphere, they create different colors.
Yeah, they get excited.
Excited.
That is actually the scientific term. They get excited.
Awesome.
It's exciting.
And
So
we're
to make
excited
our
as well.
Northern Light, you need a big glass tube.
And since this is not made from radiation from the sun, we need some chemicals. So this is boric acid. And acid and alcohol can react to make esters. This is a little shop of chemistry right now. Sorry, Brian.
Awesome. That's all right.
And actually, the most common color of the Northern Light is green with a hint of yellow. And we're going to try to make it by chemistry.
Yes. So this is a boric ester that is flammable.
Yeah. Just a little warning, this could happen really quick. So
Whoa.
Oh, that's beautiful.
Oh my gosh, that was amazing. No, I'm glad we didn't let you guys go first.
yeah, but we still this happened so fast, so we have a replay.
Wow.
Wow.
Wow, that was
But if
beautiful.
we're allowed to use a minute or so over our time, it's also possible to make other colors. One of the rarer one is red. I only seen that once, and then it was minus 20 Celsius.
Oh my gosh.
This is a bit smaller one, so it will be a bit quicker.
And what did you put in there?
Oh, that's lithium chloride. And that's kind of an interesting thing as well. So this is actually the color that your cell phone will burn at if it ever catches fire, because it has a lithium ion battery. So that's
And let's hope we don't find that out.
for anyone who's been wanting to set their phone on fire. This is for you.
Wow.
Great.
Yeah. Thank you for letting us join. We have had a lot of fun.
Thank you for doing that.
That was awesome.
Oh my gosh.
Bye.
Oh my gosh.
Bye.
Thank you so much. And you can't do that at the 2022 open house. I'm just saying.
Why not?
Thank you much. And now we're going to go over to Utah, where Adam Beehler is going to share some things with us. And Adam was a little shop. Oh my gosh. Look at that shirt he's got on. Awesome.
Oh,
From an AAPT meeting back in the day, which is
That's
awesome.
right. Can you hear my audio?
We can hear your audio just fine.
Great. So I thought I'd do a demonstration I remember doing years and years ago at the Little Shop of Physics with pressure. And this is similar. This is a way you can do it at home. I won't spoil it. I'll tell you how we did it in the day. But these are paper cups, just simple paper cups. And they aren't very strong because I'm not that
strong at all.
So you can't stand on these. So let's try it.
I like that spirit.
All right, let's see, getting the shot here. Let's add one more there. I'm going to put a board on top so I can stand across all the cups at once. All right. What do you think will happen when I stand on it?
I think it's going to crumple. I think you're going down.
So this one's just for you, Brian. I'll give you some options. It's going to crumple, or maybe one side will go down, or miraculously it'll hold me up. Okay, let's try. Drum roll, please. No problem.
Oh, yeah, got it.
nice
Evelyn and
job,
Scarlett
Adam.
are liking that one. That is awesome.
So this helps us learn about pressure. I have a certain weight. It's a force down. The earth is pulling me down, gravitational force. And that doesn't change except in COVID times. But anyway, if I can spread my weight over lots of cups, then it's a less pressure and they don't crumple. But what if I spread it over less area? Let's try that.
Ooh.
So I'm going to come back to the cups and let's just get rid of this row, shall we?
All right.
Drum roll, please.
Sheila, I think you got the drum roll. Here it goes.
It still works.
Still works. Wow.
So I must be spreading it still over enough area. So of course, less area. Let's see, just to spread this out a little better. Let's, oh, I don't know, put some, make it symmetric anyway.
There
So I
you
stand
go.
a chance. Stand on it again. I haven't changed my weight, by the way. The force is the same. All I'm changing is the area. So the pressure each one feels is different. Okay, here we go. What do you think is going to happen?
Ooh, I don't know. I think we got to try the experiment.
I think you're going to be able to stand.
I still can.
What? How many cups is that?
Oh,
Uh-oh.
see that? I was on the verge. On the verge. This I want to relate to real fast osteoporosis.
Uh-huh.
It's a big fancy word, which basically just means the stuff the bone's made out of. So I'll share this. On the left, that's healthy bone. This is like the calcium. You know, we drink and eat our calcium to get bone, make our bones up. But they have spaces in them. So if you think of the cups as your bone, inside the bone, it's like my table full of cups. And if you're a healthy bone, you got lots of cups, lots of calcium, and it can hold you, your weight. But look on the right. This is osteoporosis, which can happen to anybody, male or female. And as we age, sometimes we lose cups, we lose bone, and it can't support us. And that's what happened right over here. There's one cup, forget it. piece of cake.
Yeah, I think oh my gosh.
So there's my pressure demonstration. Thanks, folks.
Adam, thank
Fantastic.
you. That was delightful. That was delightful. Thank you for that. And thanks for joining us again. We still have stuff that Adam built back in the day, part of the Little Shop of Physics, and we're really glad that he's continued to be part of the Little Shop of Physics family. And someone else who's part of the Little Shop of Physics family is Chris Chiaverina. Chris comes to visit us every year, except not this year because, but Chris is going to join us virtually.
Hi, everyone. I'm really excited to be here for the 30th annual Little Shop Open House. Brian, thank you so much for inviting me. Now, what I would like to show you today is a strange hobby that I picked up during the quarantine. It's called listening. I've spent hours doing this. It's crazy. To do it, all you need is a solar cell and a little amplifier.
Okay.
It turns out this little Radio Shack amplifier isn't needed. You could use a Bluetooth speaker or just earbuds. They work equally well. So the solar cell will convert light into electrical impulses, which we'll hear through the speaker.
So you're saying I could just connect earbuds to a solar cell? I could connect earbuds to a solar cell?
Yeah, I did it. It's not as loud, but you can hear things.
Oh my gosh.
So anyway, this is rather boring. So let's see what else is around. It turns out that there's an unlimited number of things to look at. Oh, by the way, if you want to do this, the solar cell is available for $1 from a dollar store. So what I did to put this together is I pulled that solar cell out and mounted it on an old floppy to give it a little backing. So as I said, that's not very exciting. Let's try something that we all have or had at one time, a fluorescent light. Now what you're hearing is the 120 flashes per second produced by the fluorescent light. There are other things we can look at. For example, a tea light.
Whoa.
And it turns out that all tea lights have their own tune.
I like the first tea light. This one's a little dark.
I'm sorry?
So that first tea light is a little happy. That's a happy song.
This one?
Yeah.
You like
Play the
that?
second one again. I like that one.
It's more
And the second one's a little dark. This is like the COVID theme.
God. Not good. And then, oh gosh, I love this. This is a little light changing LED.
Whoa.
Now all these sounds in the tea lights and the LED, there's a microprocessor along with the LED that varies the brightness and the color of those different lamps. Now the question is, oh, you know what else? This is cool. Well, it's not very loud.
Is that your phone?
Yeah, the phone. Let's see about this guy. So what's kind of fun is to go around and check out displays, your flat screen, your phone, your iPad. They all produce a different pitch. Now the question is, does any of this have any practical value? And the answer is yes. Back in the mid-19th century, Alexander Graham Bell came up with what he called the photophone. And I've got a modern version of it. There's a laser, and this is a film canister and a balloon on the end, and on the balloon is a little mirror chip. So if I talk into this, maybe you can see, I don't know, can you see that on the wall?
Yeah.
Can you see it?
Whoa.
Yeah. Listen, I spend hours just looking at those patterns. It's great. It's been a rough year. Now, here's the deal. Here's the deal. Is it possible that those patterns contain enough information that if we shine it on the solar cell, we'll hear something? Let's try it. Okay.
That is awesome.
Well, you
I
know,
want to make one tonight.
uh-oh, that means my time is up.
That's if you need another minute, Chris, take it.
Okay, so the deal is the photophone didn't really happen the way he proposed it, but today we've got a counterpart that's used to get all sorts of information to us. All this is a little transistor radio, and I've connected just an LED to the output. And of course, we don't send the light through the air, we send it through fibers. And this is a very large fiber. And let's see if I'm going to shoot it through there. I don't know if you can see any red or not. It's awfully bright in here.
And there it goes.
Maybe you can you hear that?
We can hear it.
So we're sending the light through a large fiber. And as I said, that is what we use to communicate in large part today. Okay, just to recap, if you want to do this, get yourself a solar toy, tear it apart, connect it to some earbuds. You can spend a lifetime going around listening to lights.
Awesome. Chris, thank you for that. Thank you for that. That's fantastic. That's fantastic. And now we're going to show a little montage of some slides. And this is of some of our partners up at Pine Ridge. And we work with Generations Indigenous Ways and Oglala Lakota College and other schools on Pine Ridge. And this has been a really, really amazing partnership with us. And there's some photos from some of the years that we've been working with them. And there's Misty front and center, which is looking good. And here was at the open house a couple years ago. And every year we invite these folks down and they build some stuff. And there's Lauren in the center who will be joining us in a moment. And there's Misty and Lauren. I love that photo from last year's of Aw. And there's Misty and Helene. Oh, and that is like the best shot ever. And there's Sherry, awesome. So this partnership with our friends up at Pine Ridge has been really, really great. Wonderful people, very creative, thoughtful, came up with a lot of amazing ideas. And we are really, really glad to be able to continue this partnership, even in this COVID time. And we want to welcome Misty and Lauren to share some demonstrations with. And first is Lauren.
All right. I thought I was going second. So I'm doing a demonstration on a homopolar motor using magnets and copper wire. So.
And Lauren, looks like you're in your office. Is this where you teach from?
Yeah, it's my class.
Awesome. I love the shirt.
I have all this stuff here, so I figured I'd sit in here and do it today. Yeah. So, like I said, a battery, and then a neodymium magnets, copper wire. I have different sizes. I think this one's 16 gauge, and then like 20 gauge, and they're really thick. So you can make these in all different shapes and sizes. And so I'll show you guys the purpose of my demonstrations, because I use DC motors a lot in my robotics class. And this is basically how DC motors work inside. So we'll get to see how they work. So let me fix my camera. You can see my desk. First one I have is a heart.
Well, that's very sweet.
I'm gonna kill that battery playing with them.
Oh, look at that.
Oh,
Little
that's
spinning
really
heart.
nice. Wow.
That is delightful. And everybody can see what you did. That's a magnet and a battery and a piece of wire. Awesome.
And they do have to be even due to gravity. And then here's just a random one I put.
It's like an abstract. Awesome.
And then, so here's, you can actually get, let me see where I have it, but templates off the internet that'll help you shape your wire.
Awesome. Look at that thing spin.
Wow, that's great, Lauren.
And then one more, I think this one will spin a little bit faster and then it's gonna fall off. The thinner the wire, the faster it goes, I noticed.
Whoa. Yeah, that one goes like crazy.
And then let me see if this last one will work. And then I think I'll be done.
Oh, that's, ooh, that's a pretty shape. I like it. Little spiral. Man, I have to say, every time we work with you, Lauren, you come up with these new ideas of things I haven't seen before. So I am so glad that you were able to join us and show us some awesome stuff today.
Yeah.
Thank you, Lauren.
I'm experimenting. So thank you guys.
Thank you, Lauren.
Lauren.
Next, we're over to Misty.
Yeah. And first of all, we all know that I wore a different shirt today because I'm representing
Awesome.
college. I want to talk to you a little bit. I've got an activity with our, what's it called? The sci-fi tube. And we're going to show how things are connected in the form of electricity and physics, okay? But before I talk about that, well, let's do the activity and then I'll finish with a little bit of talk about being a Lakota person, okay?
Yeah.
First of all, we've got this sci-fi tube. Nothing. I put my hand on one end, nothing happens. I put my hand, so what's happening here? We're making a circuit, okay? And a circuit is like a circle. Let's see if we can do this. See,
yeah.
tapping it. It's also noisy little booger. Now let's see. Let's see if we can. What happens if we put one more person? What will happen? Let's have a little hypothesis going. If I add one more person to the circle, will the sci-fi tube react the same way?
I think yeah.
You think yeah? Okay. Well, let's see. Let's see. Okay. Okay. Now let's touch fingers.
Oh, and one finger is enough.
One finger is enough. See? One finger is enough.
I think you two should kiss.
Yes,
I think you should close the circuit that way.
I was just going to ask, is that Tony? Because I don't know if she can kiss someone else, but yes. Can you connect it that way? Could you connect it by a kiss?
I don't know.
Let's try it.
Let's try it. Okay.
Told...
He said no.
Oh,
what?
Tony, please, Tony. Please.
Oh, go ahead and hold it in one hand.
Hold it in one hand.
Oh, I see.
And then you're going
to doing it. Oh, doing it in an unconventional way. That's kind of awesome. How if you hold it in one hand and Tony holds it in one hand? Instead of touching hands, you touch lips. So give Tony a little smoochy poo. Aww.
That was great.
It worked.
That's awesome.
You guys are crazy. You make me laugh because it's a great table. now I don't know if I can get serious and talk about being connected. Personally, probably the best for me professionally that ever happened was me getting involved with these guys, and I think you all know that. We've been working with these guys over 10 years now, and every year it's a new thing. Every year I try to get more students involved, so we take some of the same ones, and then we also take some of new ones, try to get more people together. Talking about the travel of electricity in a circular motion, though, the Lakota people feel that it's a continuous pattern of life and death on Earth, and it's the shape that we find in the sun, the moon, the planets, even our family home. It's a cone, but at the bottom, it's a circle. Okay, at the teepee, it's the shape of our drum, and also some other significant pieces. It represents the outer boundary of the Earth, and often that's referred to as the Sundak Circle or the sacred hoop. It helps us remember that it represents the continuous growth of life on Earth between life and death. Everything in the universe is related, and it tells that the things exist now, everything, the plants, the animals, all the people in the world, that we're all connected in one continuous process, just like this electricity was. So just to let you know, the term that we say is mitakiwase, which means all my relatives. So I guess that's a Lakota's way of saying we're all connected.
Misty, that's
Misty,
wonderful.
thank you.
Thank you.
A wonderful demonstration and what you said. I wish I could speak that eloquently, because you've really kind of summed up the importance of staying connected in this time. So Misty, thank you for joining us. Lauren, thank you for joining us. And Chris and Adam, our friends at Science Circus, and all the people who are watching on Zoom, on Facebook. 2022, we are going to do the Little Shop of Physics open house as it was meant to be done. We're going to have a bunch of stuff. We're going to put our hands on it. We're going to talk face to face. And until then, don't forget, we're all still connected. Thank you so much.